Okay, so we see with these forces here, they're suspended in equilibrium. So again, we've got the word equilibrium, so they're balanced. But in the case here, suspended means that this is happening in the vertical plane. Okay, so literally this is hanging here by reason of the fact that we've got strings attached to it. Okay, so in A then it says, only with 1 mark, it says find in newtons the tension in the string OP. Okay, so in regards to part A, again, because it's only worth 1 mark, we need to appreciate the fact that at P, we've got an object, okay, of mass 30 kilograms, and it's not fallen, it's balanced, it's held there by means of this string, okay? So the string is taking this weight, okay, and balancing the object. So we've got our object of mass 30 kilograms, so the weight will be 30 g, and then we've got the string then, okay, the tension in the string, and it will balance, won't it? Okay, so we can say in this case that T is equal to 30 g, the tension in the string is equal to the weight so that there's no movement. So 30 then times 9.8, and we work that out, we get 294 newtons. Okay, so B then, it says draw a diagram showing the forces acting at the point O. Okay, so now we're going to focus at O. Again, remember it's in equilibrium. Okay, and we give them 1 mark to draw a force diagram. Okay, so we need to appreciate here that we've got B going at an angle of 60 degrees to the vertical. So we'll draw the vertical in here. We need to have the angle in there, 60 degrees. We've got A going at an angle of 45 degrees. The string going to A. And then we've got the force then at P, which is essentially the tension in this string. Okay, so we've got the force in the string O to B, which is, and then the force in the string O to A. So we can call that maybe T1. We'll call this tension T2. Okay, and then we've got the tension in this string, which is obviously being pulled down by the object, and we know we've already worked that out to be 294 newtons. So there's our force diagram. Okay, so we've got there our mark there, but of course then when it comes to C, where we've got 8 marks, it says calculate the forces in the strings OA and OB. What we need to do then is, of course, is to work out T1, work out T2, and we need to have our cross situation, yeah, first and foremost. So our cross situation, in order to establish the components in each direction. Okay, so for this question, I literally can say this is the horizontal and this is the vertical, because it's been suspended. So we've got 294 going down, the weight. Now, with regards, let's do T1 first. The angle here is to the vertical. Okay, so the angle is contained here to this side, so it'll be cos on this side, so it'll be T1 cos 45, the component there. And then going this way, the component going this way will be T1 sine 45. Similarly then for T2, because the angle is contained to this side, it'll be cos, so it'll be T2 cos 60, and then the opposite then, T2 sine 60. Okay, now these are all in equilibrium. Okay, they're balanced. So when we resolve, we can resolve horizontally first. We can say that T1 sine 45 is equal to T2 sine 60. Okay, and of course then sine 45 is quite nice, sine 60 is nice. If you do that on your calculator, you'll get root 2 upon 2 for sine 45, T1, and then sine 60 is root 3 upon 2. Okay, T2. Now, if we multiply through by 2, we'll get root 2 T1 is equal to root 3 T2. So it's quite a nice sort of equation there. We'll leave it at that, we'll call it equation 1. When we resolve vertically then, okay, well, we've got these two forces combined here going upwards, T2 cos 60 plus T1 cos 45, that will equal to 294. Okay, so again, if we use our calculator, this will be T2, that'll be times a half, cos 60 is a half, and then T1 times cos 45, that's root 2 upon 2, which is 294. Multiply through by 2, you get T2 plus root 2 T1 equals to 588. Okay, that's equation 2. Now, of course, we can use equation 1 and equation 2 then to solve, to work out what T2, what T1 are. Now, of course, in this case, we've got root 2 T1 here is equal to this. So literally, I could replace root 2 T1 with root 3 T2. So I can say, look, sub 1 into 2. So I'll get into that T2 plus, so instead of root 2 T1, I can write what root 2 T1 is equal to, which is root 3 T2 equals to 588. And then here then I can factorize out 1 plus root 3 T2, which is 588, and I can get then my T2, 588 divided by 1 plus root 3, so I can work out my T2, which on my calculator says it is, I've got 215.22 newtons, and then of course then you just literally then sub it in to equation 1, okay? So root 2 T1 is equal to root 3 times the answer there for T2. So T1 then will equal to root 3 times 215.22 over root 2. So my calculator, I'm going to type in fraction root 3 times answer over then root 2, and I get 263.59 newtons.